To start with this playlist, let's talk about the complex integral of f of z along a certain c. In complex analysis, the complex integral, also known as a contour integral or line integral in the complex plane, is the extension of the idea of integration from real functions to complex valued functions of a complex variable. Take note, we are now on the complex plane, and then therefore there is additional concept when we talk about the integration or the integral of a certain function. This time we are going to talk about the integral of function of z. Now there is a certain c here. This c is actually known as the path or the curve of the certain function. Now let's us have here the formal definition of the complex integral, which we could also use later on in some of the few examples and illustrations. We have here, let f of z be a complex function defined on a smooth curve, or the other term for that is contour, c, that's the curve in the complex plane, if c is parameterized by, let's say we have here z is equivalent to your z of t. We're going to make sure that there will be some parameterization of our function z in terms of t now, where our t is between a or b, the endpoints of your curve, where you're going to determine later on, where z of t is of course continuous along the curve and differentiable as well. Then you have here, sorry for that, let me do it again. Then the complex integral, here is its form now, integral of your f of z, let's say here along your smooth curve, which is c, is defined as, this is the equivalent form or equivalent value for our, or expression for the complex integral along the c, the smooth curve c, or the contour, is actually the integral of your c here, f of z dz is equal to the integral of a to b, your endpoints for your identified curve, or the endpoints in that curve that you're going to use, of your f of z of t times the derivative of your z of t dt. Now take note, this is actually the parameterized form, of your function, which would be illustrated later on as well. In words, or in simpler words, the complex integral of your f of z along your contour c is obtained by substituting the parametric form of the curve into the function f of z. Instead of f of z, it will become in this form now in terms of t, then multiplying by the derivative of that, of your z of t, then integrating with respect to t. The result of this would be equivalent to the complex integral, the complex integral of your function along your contour or smooth curve c. So later on, we're going to look at some examples later on where we'll be asked about the complex integral of a certain function, along a certain c, which would give us the endpoints of a and b depending on your parameterization. But of course, the process of parameterization, of course, as well, later on will be illustrated by an additional video. But this is actually the complete definition of the complex integral of f of c along c. This means there are items here you need to consider. Number one, the parameterization of your contour or your smooth curve c, in this form here, where a and b are points on that c, or points of your the endpoints of your certain t with respect to your z, and then later on the integral of that is actually the complex integral is the integral of your parametric function times the derivative of your z of t with respect to the t. We will have illustration for we will have some illustrations later on with regards to the solution of this. Okay, so please watch out for that. Thank you very much for watching.